Hello, friends. Grab your coffee, grab your cookie, preferably not a cookie made from corn, rice, oats, or barley, because today we are talking about grain and cereal dusts. Yes, the dust that somehow smells like breakfast but behaves like a combustible industrial hazard. My name is Michael Klepik, and for 15 years I have been designing dust collection systems for grain mills, feed mills, bulk grain elevators, cereal processing plants, flour production, and agricultural handling systems. Let me explain what unites all these grain dusts and how we control them safely. What all these grain dusts have in common: corn dust, rice dust, oat dust, barley dust, wheat dust. These are all agricultural cereal-based dusts generated during first, milling, dehulling, cracking, and grinding. Second, grain conveying, bucket elevators, augers, and belt conveyors. Third, pouring, dumping, and transfer operations. Fourth, screening, aspirating, drying, and cooling. Fifth, bagging, packaging, and bulk truck loading. Although each grain differs chemically, all cereal dusts share the same engineering challenges. First, they are organic and fully combustible. Second, they form explosive dust clouds easily. Third, they are lightweight and highly airborne. Fourth, they absorb moisture and become sticky inside ducts. Fifth, they contain starches that burn rapidly and violently. This is why grain dust is classified as a high-risk industrial dust. Technical characteristics of grain and cereal dust. Here are the typical physical properties of cereal dusts. First, particle sizes usually range from 1 micron to several hundred microns. Second, the most explosive fraction is from 20 to 60 microns. Third, bulk density ranges from 200 to 500 kilograms per cubic meter depending on grain type. Fourth, airborne dust concentrations can reach from 1,000 to 30,000 milligrams per cubic meter during milling. Fifth, dust contains starch, proteins, fibers, fats, and natural sugars. Starch-rich dusts like corn and wheat ignite especially rapidly. Corn dust, highly combustible and very fine corn. Processing produces extremely fine dust. First, high starch content increases explosion severity. Second, particle sizes commonly fall between 5 and 50 microns. Third, dust is fluffy and remains airborne for long periods. Fourth, bulk density is lower than many other cereal dusts. Fifth, corn dust is notorious for secondary explosion events. Corn dust clouds are some of the most reactive in the agricultural industry. Rice, oat, and barley dust, light, fibrous, airborne rice, oat, and barley dusts behave differently but share similar hazards. Rice dust first, often contains sharp husk fragments. Second, can cause eye and respiratory irritation. Third, produces moderate dust loads. Oat dust, first, extremely lightweight fiber fragments. Second, stays airborne for long periods. Third, often carries oils that affect filtration. Barley dust, first, common in breweries and malting. Second, contains husk fibers and starch particles. Third, generates heavy dust in conveyors and malt mills. All of them form explosive dust clouds, especially during conveying and sifting. Why grain dust is dangerous. Grain dust hazards include: first, high combustibility due to starches and organic content. Second, low minimum ignition energy. Even a small spark can ignite it. Third, dust layers as thin as 1/16 of an inch can fuel an explosion. Fourth, respiratory irritation and allergic reactions. Fifth, dust buildup attracts insects and rodents. Sixth, dust interference with sensors, motors, and bearings. Agricultural dust is responsible for some of the most severe industrial explosions in North America. Physical behavior of grain dust in airflow. From an engineering perspective, grain dust behaves like classic organic combustible dust. First, it floats easily because of low density. Second, it forms clouds instantly when disturbed. Third, it absorbs humidity and forms sticky layers in ducts. Fourth, starch particles embed deeply into filter media. Fifth, it generates static charge during pneumatic transport. This is why I designed duct velocities from 4,000 to 5,000 feet per minute for cereal dust. What filtration equipment works best for fine cereal dust? I often use a foliage and cartridge collector. First, it captures fine starch particles efficiently. Second, it offers strong pulse cleaning. Third, it provides high filtration area for continuous milling for heavy dust loads. A Baghouse blizzard is ideal when: first, large volumes of mixed particle sizes are produced. Second, long operating cycles are needed. Third, fibrous husk particles are present. Explosion protection. Agricultural dust always requires: first, explosion venting. Second, duct isolation valves. Third, anti-static filter media. Fourth, grounding and bonding across all equipment. Fifth, optional spark detection for mills and grinders. There is no such thing as a safe grain mill without explosion protection. Capture hood, designed for grain. Handling. Proper hood design is essential because cereal dust escapes easily. Effective methods include: first, enclosed hoods above grain transfer points. Second, capture in bucket elevator head and boot sections. Third, dust pickup at hammer mills and roller mills. Fourth, side draft hoods at bag dumping stations. Fifth, telescopic loading spouts with integrated dust removal. Good capture reduces airborne cereal dust by more than half. Grain and cereal dust, from corn to rice, oats, barley, wheat, and everything in between, may smell like food, but they behave like a serious combustible hazard. They are lightweight, energetic, sticky, and capable of forming dangerous dust clouds. With proper airflow, high-efficiency filtration, and full explosion protection, we can control grain dust safely and effectively. I am Michael Klepik. Protect your lungs, protect your equipment, and remember, cereal belongs in your breakfast bowl, not floating around your facility. See you in the next video.